This video is about the geometric interpretation of the vector product. We've already encountered that the magnitude of the vector product is the same as mag A, mag B times sine of the angle between them. So if we imagine what this would look like, here's our vector A, here's our vector B, here's the angle between them, this should look pretty familiar from GCSE. That the formula for the area of this non-right angled triangle would be half AB sine of the angle between them. So we knew this from GCSE, and we can see that this formula here is just double the GCSE formula. So one way of interpreting the magnitude of the cross product is that half the magnitude of the cross product is equal to the area between the two vectors that make up the sides of the triangle. Therefore, obviously, if we extend from a triangle between the two vectors to a parallelogram, the area of the parallelogram between those two vectors is the magnitude of the cross product. Now if we move from area to volume, the proper name for this shape is a parallelepiped, but it's basically a wonky box. So if you imagine a cardboard box that's been given a really good kick, so it's gone out of true in every dimension, so none of these angles are 90 degrees anymore. But the sides of the box can be described by vectors A, B and C, where the volume of that box would be the scalar product of one side together with the vector product of the other two sides. It doesn't matter which way you arrange the three sides here, but if you take, and this is called the triple scalar product. Now if we go from a parallelepiped to a tetrahedron is a triangular base pyramid. So I've got the same basic construction. I've got three vectors, except instead of making them into a box, I've just joined them up directly. Down here is vector B. It doesn't quite get onto the screen. So a triangular base pyramid, the formula for this one is 1/6 of the triple scalar product. Now, you might be able to spot that this links with GCSE as well. At GCSE, you would have known that you could have found this volume by doing 1/3 base area times height. And you would also know that the base area would be a half AB sine C. So the 1/3 and the 1/2 in the formula for the base area are where the 1/6 comes from. So there's nothing magic or new here really. This is just a GCSE formula expressed in a slightly different way.